Hello and welcome to the Introduction to Python. Over the next hour, I'm going to be talking through some of the foundations of Python, and my goal is by the end of this talk, you should be comfortable enough to go out and write your own Python applications and programs. This is the agenda that I'll cover for the next hour, starting with a welcome, discussing what Python is, why you would use Python, going through most of the time talking about Python basics, and then I'll close with next steps and share some resources so that you can continue learning. My name is Megan Lewis, and I'm a senior program manager at Microsoft. I focus on reactors and creating content and going out to speak at reactors. So I have an edge for emerging technology in particular, which means I get to spend time going out to explore and tinker with some trending technologies that really have the impact to make a positive change in our society. I'm currently focusing on things like blockchain and quantum computing. And I'm always just out looking for new and great content to bring to reactors. If you'd like to get in touch, I left my contact information there below. Please feel free to connect with me on Twitter or LinkedIn if you have any questions about the reactors, about any content, or if you just want to get in touch. I'd love to hear from you. Microsoft Reactors are worldwide community spaces where we offer free learning in the forms of workshops, tech talks, we host meetups. It is a great space to come together and learn from one another, and also just to create a network of fellow technologists who enjoy learning about new topics. Below, you can go to check out the Reactor website at developer.microsoft.com/reactor, or you can also reach out to us at the Reactor Twitter at MSFT We have a very active Twitter community, so we'd also love to hear from you there. So now let's get into the Python material. So what is Python? Python is the fastest growing programming language. While it's been around for over 3 decades at this point, Python still continues to grow in popularity and usage. According to the Stack Developer Overflow survey, Python is the 4th most used programming language, just behind HTML, CSS, JavaScript, and SQL. It is also the 2nd most loved language and the 1st most wanted language. So what that indicates is that while millions of users already are using and enjoying Python, there are probably a whole other million or millions of people who are interested in learning and using Python for personal projects, for work, or for school. Python is human readable, so the syntax is very simple and readable without a lot of heavy syntax rules. It is multifunctional, which means it can be used for web development, including both front-end and back-end. It could be used for data science and automation scripting. It is also very flexible, so it allows multiple approaches to programming, including object-oriented programming, functional programming, and procedural programming. Python is also very compatible, so like a lot of other programming languages, Python can be run on any operating system. So why would you want to use Python? Like I mentioned on the previous slide, it has a very human readable syntax, and that makes it very easy to learn without having to also learn a lot of the different syntax rules. Because of this, Python is now becoming one of the most taught programming languages in universities and coding boot camps. Python provides an extensive set of libraries to get you started and to provide code to help you write a bunch of Python applications. So chances are whatever you might want to do in Python, there's already a library out there that will support you in doing that. It is used very widely in the tech industry, so leading social networks, video streaming services, and social engines use Python. Just to name a few of the different companies, we have Google, which has created a deep learning framework called TensorFlow. They also use Python in their app engine. Facebook and Instagram have been using it as a prominent language in their environment for years, and Uber and Lyft also use Python for various use cases as well. And Python is also a top programming language for data science and machine learning. So it has packages that are great for those purposes for data science and machine learning. There are packages like NumPy and Pandas, which are great for data manipulation and cleaning. There is a graphics library or graphics libraries. So there's Matplotlib and there's Seaborn. And there's also some great machine learning libraries out there, such as scikit-learn and TensorFlow, like I mentioned previously. So that just goes back to the second point there about there being an extensive amount of libraries to really kind of do anything that you can dream of with Python. So for the next portion and kind of for the remainder of this course, I'm going to be walking through some Python demos. And so to try this out, you need the following tools. You're going to need VS Code as the editor, Python as the programming language. You will need the Jupyter package. So Jupyter is an open source project that lets you easily combine markdown text and executable code in one canvas, which is called a notebook. And then you will need the Python extension for VS Code. So the Python extension for VS Code allows you to run Jupyter notebooks directly from within VS Code. So you need to install that. And if you want to try this out at home later, or if you're watching this video, you can go ahead and pause the video and go in and set up those tools. You want to start by navigating to aka.ms/reactords_python. And there you will find a couple different files. So one of them is the setup.md file. So in that markdown file, you will find a list of links to go out and download the tools that I mentioned on the previous slide. You'll also find the Python notebook that I'm going to be using. So that file is called python.ipynb. So if you right click on that file, you can just select Save As and go ahead and save it to your desktop or whatever location of your choice. And then go ahead and open up that file in VS Code and install the Python extension. Then you can start using the file python.ipynb. Excuse me. So now let me go ahead and open up this notebook in VS Code and get started. All right, so I have transitioned over to VS Code, and in here I have opened up the Python notebook, python.ipynb. And so now let me take the next 30 to 40 minutes to walk through some of the examples in this notebook. And before I do that, I will just have a little bit of a primer on Jupyter notebooks. If you are unfamiliar with them, no worries, you will quickly become familiar with the functionality that the notebooks provide. So if I look at this first box here for comments, as I hover over them and click into them, I see that this individual box was highlighted. And so what we call each of these is a cell in Jupyter notebooks. So here I have a markdown cell, and that's indicated by these curly braces in the left-hand corner. And then when I use my arrow to go down to the next cell, I see that this is an executable cell. And that is indicated by this play button. And then when I hover over that, I can see that I can run the cell. So to run the cell, I can just click on this run cell button, or I can also use the shortcut Command Shift to run that. And you'll notice a couple different things happen there. First, to the left, I see that a number was put inside of these square brackets. And then I see the results of that cell executed immediately below. So it's just a great way to very quickly be able to write some code and execute it and see results. So now let's get into the content. So let's start with comments. As you can see here, comments are indicated by this hash symbol. So comments are very commonly used within programming languages, not just Python, but they can be a great way to provide more description about what your code is doing. Yes, Python is human readable, but it's sometimes helpful to provide a little bit more context about what this piece of code is going to be doing, what this function is, what information that you need to pass to the function to use it. So it's often helpful to leave comments in your code, either for yourself or for other readers as well. So moving down the lines of the cell block, I see next on the second line, there is a variable called spam, which we assign a value of 1. And then after that variable, there is a comment. There's also a comment on that third row. And in this fourth row of the cell, there's a variable called text. And for that value, we are assigning a string, which is indicated by these double quotes. And inside of that, there is this comment. Then on this last line of the cell, I use the built-in function print and pass in the parameter of text, so that variable defined on the line right above it. And then when I print that out, I see the result. This is in fact not a comment because it's inside of quotes. So this is just a quick primer on comments, and you'll see them a lot throughout the rest of this notebook. And also just helps identify that comments within quotes are a string, and they will not be rendered as comments. So now let's get into the Python basics. And I'm going to start out with just some arithmetic and different numeric types. So as I move forward, I see that there is this print built-in function that we just used in the previous example. And this is a great way to just easily print out any values. This is taking in a string, but you can put other types as well, as we will continue to see throughout this notebook. So for numeric operators, we use kind of these items here. So this is very similar to the convention that other programming languages use, but you just use plus, minus, you use the asterisk for multiplication, and the / for division. So pretty straightforward. So if we do a 2 plus 3 on those two integer types, we get a 5. The order of operations also works as it does in other programming languages. So here I have 30 minus 4 times 5. So it's important to do the multiplication first and then to do the subtraction after that. So note what happens when you use division. So here I'm saying 7 divided by 5, and that leaves me with 1.4. And so this introduces the concept of floating point numbers. So floating point numbers are simply decimals. Any decimals, positive, negative, but they are just decimal numbers as opposed to integers, which are whole numbers. And you can mix numeric types in calculations. So I can say 3 times 3.5, which gives me a float of 10.5. 7.0 divided by 5 gives me a float of 1.4. And you can also perform a special type of division called floor division. So floor division uses the double division operator, and it just discards any remainder. So 7 with a floor division of 5 will just return a result of 1 without that remainder of 0.4. It just gets rid of that. And then I can use the modulo operator to essentially do the opposite of that. So here I just want to specifically calculate the remainder. And when I run that, I get a remainder of 2 using the modulo operator. So for exponents, I can use that double asterisk operator. So for 5 to the power of 2, I can say 5 asterisk 2, and that will give me 25. Conversely, 2 to the 5th would give me 32. And so now let's look at a couple more operations here using the exponent. So if I say -5 to the power of 2, that is essentially the same thing as 5 to the 2 negative. So that would give me -25. But if I use parentheses to specify that I'm saying -5 to the second power, so -5 times -5, I will get a 25. And then parentheses can supersede the order of operations. So in this example, I would do what's in the parentheses first, which would give me 26 times 5, which is 130. Now let's talk about variables. So variables are a very key part of any programming language. Variables are a key part of any programming language. So this is essential for saving values for later usage. And if you've used programming languages before, you know all about variables and why you need variables. But let's talk about what makes variables specific to Python. So here what I'm doing is defining 2 variables. I'm saying length is equal to 15 and width is equal to 3 times 5. And then I'm doing an operation on those two variables of multiplication. So if you notice here, I am simply assigning a value to those variables. So I'm assigning integer values, but I do not have to worry about taking the time to actually define the type for those variables. So that's pretty cool. Python just will know the type based on the value that is provided. So it makes it super easy to just go ahead and declare variables like on the fly. And here are just a couple more examples of some of the data types that I might assign to a variable. So I have an integer, I have a floating point, and then here I have a string. And note that for all the flexibility of variables in Python, you still do have to define them. So I can't just go and call some random variable that doesn't have a value, or else I will get an error that this variable is not defined, which makes a lot of sense because, again, it needs a value. In Python's interactive mode, you can use the built-in variable of this underscore, which automatically takes in the last value of the printed expression. So here I am defining a tax rate variable. I'm setting a price for an item, and then I'm doing a multiplication operation. So as a result of multiplying the price and the tax, I get 2.25435. And here in this next cell, what I can say is price plus underscore. So what that's going to do is to take the value of price and add that to the last outputted expression. So I would get 19.95 plus this variable, plus this value here, which is 2.25. And then I'm left with 22.20, so on, a long floating point number. And then I can start to introduce some more interesting concepts, such as another pre-built-in function called round. And so what round does is here, and if I hover over this function, I get a nice definition of this function. So I see that it takes in a number and a float. So the number can be any number, and the float is just describing the number of decimal points precision to output that number. So I'm saying take this last value here, 22.20, so on, and include up to 2 decimal points as a result. And here I'm just left with 22.20. That last zero is just dropped. So you can also define multiple variables at one time. So just doing this in a single line by comma separation, I can define 3 variables at one time or more. And notice that these variables do not have to all be the same type. Again, Python will just figure out what the type is based on what value is passed to it. So this is a really nice way to just define multiple variables at once. And then you can also augment the expression. You can also augment the variable assignment. So here I have x is equal to 5, and then I'm saying x is equal to 5 plus 1, which will give me 6. And then I can do 6 plus 1 is now equal to x, so that's going to give me a result of 7. And so let's now talk about some of these augmented assignments. So here, again, if you've used other programming languages, you're familiar with this, but I can use the plus equals to just say x plus this value is equal to x. There's also similar augment assignments that I can use for the for the minus sign, for multiplication, for division, modulos, and so on. So next I'm going to move into expressions. For expressions, they are very critical for decision making. And typically here we're going to use comparison operators to help us make decisions, or help our Python program make decisions. So we'll start out with some simple ones like 2 is less than 5. And so here we get a Boolean value of either true or false. And we know that this is true. So here are the list of all the comparison operators available to Python, and these are all probably very familiar to you from your basic math classes, or other programming languages as well. We use the double equal sign for equality, and the exclamation point equal for inequality. And all of those, again, output with either a true or false Boolean value. So Python does not restrict you to comparing just 2 operands at a time. For example, I can have 3 different variables. A, B, C is equal to 1, 2, 3. And I can say, is A less than B less than C? So when I evaluate that, I see that that is true because 1 is less than 2 is true and 2 is less than 3 is true. So both of those comparison operations are in fact true. Then I can also use some built-in functions to compare data. So these can be very helpful as I start to have very long lines of data or, large amounts of variables. This can be really helpful to just quickly take the minimum or the maximum. So these built-in functions can definitely come in handy in the future. So just good things to remember. I can also combine comparison operators into compound expressions. For example, 1 is less than 2 and 2 is less than 3. So again, both of these will evaluate to true, which will give me a result overall of true. Now, let me look at a very similar example, but instead of saying 2 is less than 3, I'm saying 3 is less than 2. So that first statement will be true and the second statement will be false. So that will evaluate to false overall because I'm using that and operator. When I use the or operator, there is a little bit of a different result. So 1 is less than 2 is true, or 1 is greater than 2, which is not true. But overall, that evaluates to true because just one of those statements needs to be true for a true result. And finally, not inverts the truth evaluation of an expression such as not 2 is less than 3. So 2 is in fact less than 3, but using that not operation, I get a false as a result. So now here's another exercise, and this starts to play around with compound expressions. So here I can just start out with a default of I, but if you're going to do this on your own, I definitely recommend trying out some different values of I, but let's just walk through what this example would return. So here, 7 is equal to 2 would give me a result of false, or 7 modulo 2 is not equal to 0, which is true, and 7 is greater than 1, and 7 is less than 5, which would give me false. So I have true or not true and false. So true or not false is going to go ahead and give me a result of true. And again, if that didn't make sense, take some time to pause and kind of go through, input different values for I and see what the result gives you there. So now let's move on to talking about strings. And just to introduce another data type, we've seen strings used a little bit so far, but this will just go a little bit deeper into how you use strings. So strings can be defined inside of either single quotes or double quotes. So I just see the result here. I see that if I use single quotes, I have to use the / character to escape special characters, like that apostrophe there. So that will just result in doesn't. I can just go ahead and use double quotes instead if I don't want to have to worry about escaping any characters. And as I scroll down and look at this example, I see a string that is surrounded by single quotes, but inside of that, the word isn't is surrounded by double quotes. And then I'm also escaping that apostrophe. So when I do that, I basically just get the string as it is because I'm using kind of a combination of double and single quotes. It just prints out exactly what it is. Now let's look what happens when we use this print built-in function. So when I kind of do the same thing inside of that print function, if you remember from before, the print function will remove the surrounding quotes for the string and just print out the string value itself. So it got rid of those single quotes and just left me with the double quotes around isn't, she said. So hopefully that makes sense. Now let's look at a couple more examples of using this print function. So here in this line, I have a single quote string, and I'm providing some file name some file path rather, sorry. And here I see that this \n, if you're familiar with that convention, that will mean new line. So when I print this out, I'm left with C, sum, and then aim on the second line, which is probably not my intended result. So in the second example, I can print, and then before I pass in the string in single quotes, I want to add this R, which means to use the raw string. And so then I can see that that will print out the path as I might expect it to. And instead of using that raw string, again, I can just use double quotes here, and that would just be fine as well. So now let's look into string literals. So string literals are either delineated by triple quotes, so either the double triple quotes or the single triple quotes. And this is just a way to create multi-line comments. So this can be a great way if you have a very long comment that you want to add and you don't want to have to just add the hash symbol for every single line of the comment. But if I run this, I can see that that evaluates to basically one long statement with this new line indication between each of the new lines. So one thing about this is it's not as readable. It's definitely not as readable when you're executing your program. So for this reason, a lot of developers will end up just using the hash for a single line comment instead. And that's also why it's very convenient in this notebook as well, because we don't actually see the output of the comments as well using the single line. So now let's look into some string concatenation. So in this example here, I have a couple different things going on. So first I'm starting with an integer and I'm saying times this string of un, and then I'm concatenating that or adding it with this string of em. So when I do that, again, think of the order of operations and what's going to happen here. So I end up with un, em. And now I'm going to dive into more examples of concatenating strings to make sure that this is really reinforced. So when there are two or more string literals placed next to each other, they're automatically going to be concatenated. So here I would just be left with Python. However, to concatenate variables or a variable in a literal, I would need to use that plus sign. So then I would have a prefix variable with a string literal value of pi. And then I can say prefix, so pi plus thon will give me Python. And now let's talk about indexes. So strings and other data types can be indexed by using this notation here. So by calling the variable and then in square brackets passing in an index, and then that index will take in a variable. So in this situation, when I take word of index 0, I am left with p. So p is in the index 0 spot, y is in index 1, T has index 2, H has index 3, and so on. So when I do word of index 5, I'm left with N, which is the character in position 5 or the last character of that word. Indices also may be negative numbers, which means to start counting from the end of the string. So from the beginning of the string, we start with index of 0. From the end, there is no negative 0, or rather that's the same as 0. So what we do is we start from negative 1. So when I say I want the negative 1 index of this word or string, I get an N. Word of negative 2 would give me O, and word of negative 6 would give me P. So we'll come back to more examples of indexing later, but now let me introduce this concept of slicing. So slicing is a great way to get a range of a data type, or in this situation, a string. So if I look at this example, I'm taking the word variable and I'm looking at the range from the 0 position up until the second position, with 2 being excluded. So when I execute that, I see that I get pi. And next, when I look at the slice from position 2 up until 5, with 5 being excluded, I get though. So that takes the second, third, and fourth index. And when I omit either position, the default start position is 0. So this will give me pi, since it's taking the 0 and the first indexed. Going from 4 to the end, I get O and N, since that is taking the fourth and the fifth index. -2 to the end would give me on, since it's taking -2 and -1. And then there's also some other ways that you can represent slices. So, and these two next examples, I'm looking at different slices of word. So from the start up until the second position, plus the word from the second position to the end. So what that does is just give me the whole word, basically, the whole string there. And so now let's look at a couple examples where the range that we provide in a slice is out of bounds, actually. So here I'm saying, let's look at the 42nd index of word. But as we all know, there are not 42 indexes in the word Python, since we've only seen that there are 5. So here, when I try to access a index that is out of bounds, I will see this error result of string index out of range. However, when used in a range or when used in a slice, I don't get an error in this situation. So here what I'm doing is taking the starting point of index 4 up until 42, but I'm only going to get a result of what is available as part of that word and nothing else. Similarly, if I just pass in a range that doesn't make any sense, so I'm starting from the 42nd position to the end, I would just get an empty string here. So Python strings are immutable. And if you're not familiar with the term immutable, it just means that the values cannot be changed. So immutable means that the value cannot be changed. So let's look at what that actually looks like here. So here I'm saying, let's take the 0 index of word and assign that to J. And immediately I get an error saying that the string object does not support item assignment. And that's just a good way to indicate that this data type is not immutable, is immutable. So keep that in mind, and we'll see more examples of different data types and what is immutable and what's not. So when I am now looking at the slice, I am saying, let's say the word, let's take the word, and from the second index to the end, I want to assign that to pi. And similarly, this also produces an error just to say that string object does not support assignment. So kind of same thing, no matter if we're trying to use a specific index or we're trying to use a slice, that we cannot change that string value because it is immutable. So a slice is itself a value that you can concatenate with other values using a plus. So this example, I am saying there's the string J, and I want to concatenate that with the word from the first position to the end, which would result in Jython. So it is okay to concatenate and to evaluate this expression because I'm not trying to change assignment here. Similarly, I can do the same thing here. So just looking at another slice example and concatenating that with a string, I have the result of pi. And here I am trying to have a slice of word from the 0 position up until the second, and then I have the string literal of pi. So if you remember a couple examples up, I had 2 string literals next to each other, and it was able to concatenate that immediately. But because of this format, I cannot just automatically concatenate a slice and a string here. Those are 2 different types. Oftentimes while working with strings, it can be useful to evaluate the length of a string. So here you can use the built-in function length, and then you can see the length of that string. So this can be helpful, of course, with very long strings where you might need the length and you might want to know, what you can slice by, what you can index. So this can be helpful to get more information about that string. Another useful built-in function for working with strings is the str function. So this just takes any data type and we'll go ahead and convert that to a string. So I can pass in an integer or float, another data type, and just go ahead and convert that to a string. So now let me get into some other data types. So let's start with talking about list. So lists are a sequence of comma separated values, and they are contained in square brackets. So here I just have a list of integers, and when I execute that, I can see that list of integers printed out. Like strings, list can be indexed, so squares of 0 will just give me 1, squares of -1 will give me 25, and I can also slice list. So a square of -3 to the end will give me 9, 16, and 25. And then if I just pass in a slice operator, just using this colon, that will just give me a new shallow copy of the list. So here, basically, I just get the list back itself. Lists also support concatenation like strings do. So here, if I'm taking my original list and adding this other list, I just end up with one long list. Unlike strings, which are immutable, lists are immutable type, so I can change any value in the list. So say that I have this list of cubed values. I see that something might not be right with one of these values in the list. So 4 to the third power is actually 64 and not 65. So if I do cubes of 3, so looking at that third index there, I can assign it a new value of 64. And then when I print that list out, I can see the new value added in that third index. So you can also assign to slices, which can change the size of the list or clear it entirely. So here I'm defining a new list with these letters. I am replacing the values in index position 2 up until 5. And now I replace those, so I have a capital C, D, and E in the middle of that list. Then I can go ahead and remove them with this notation here. And then I can clear the list by replacing all the elements with an empty list. So here I'm saying take this list and just replace it with an empty list. And then I am left with an empty list. So I can also use that length function on list in addition to strings and other data types to get the length of that. Then you can also nest lists that contain other lists. So here I have a list A of strings, a list N of integers, and then I can say X is equal to A and N. So I'm creating another list composed of these two lists, which just gives me this nest here. And then when I access or provide the index for this X list, I would get just the first list within that. And when I do X of 0, I'm just left with A. And similarly, if I do X 0 of 1, I would just be left with B. So this can be a nice way if I want to create a kind of multi-dimensional list and access values within those. Now let's explore some list object methods. So here I'm defining a list of Beatles with two string values, John and Paul, and then I can append the name George. And when I do that, that string value is just added to this list directly. Notice that you didn't actually pass a list to append, we just went ahead and passed a string. So I can also use the append function to pass in a list. And then what I would be left with is another list within a list scenario. But to go ahead and tack a list onto the end of an existing list, I would just use that extend function. And then that would just tack those on and not put them off in their own list. I can use the index function by providing a value in the list, which will tell me the position of this value. I can use the count function to pass in a value from the list, and that will tell me how often that this occurs in the list. So that can again be very helpful when you're working with large list and you know that you're looking for something specific. This can be just a great way to find it, either using the count or trying to find the index or location of that value. And there are two methods for removing items from a list. So the first is going to be remove. So here I can just go ahead and pass in a value from the list again. And when I do that, Stewart is removed from the list. Another method for removing items from the list is the pop method. So when I say Beatles.pop, that will go ahead and remove the last item from the list. And I see that that gives me Pete. And then I can go ahead and also insert items into the list. So if I insert into the first index, I want to insert Ringo. So that will go ahead and insert Ringo into that first index there. There is also the reverse function, and this probably does exactly what you might imagine and just reverse the order of the list. And I can also sort. So this will sort alphabetically in this situation. Of course, if my sort is for integers or floating types, it would also sort those numerically. Okay, now let's get into tuples, which are another data type. And this data type is pretty similar to list in that it is a sequence of values, but tuples are immutable. So let's just look at first how you define tuples. So again, very similar to list, but instead of using square brackets, I'm using parentheses to define what's in my tuple. And I get these values here. These are all integers, but I can use different data types as well. So I can use integers and floats or, strings as well. Because tuples are immutable, you cannot change values within them. So I can't just try to update values. And I get the same kind of error message that I did with the string type here, just telling me that this object does not support assignment. So Python's just really good at letting you know when you're trying to do something that's not allowed, you'll get an error message, and hopefully that's clear to understand what rules that you're violating. However, you can still refer to elements within them, so you can still do indexing. You can still do slicing, so this will give me just the 0 index and the first index of that tuple. And you can also create tuples from list. So as we saw with that string function, when you can basically use that to convert anything to a string, you can also create tuples from list, or vice versa. You can create lists from tuples. So there's lots of ways to convert the data types that you're using into whatever it is that you're looking for. And maybe you might create a tuple and you realize, oh, I actually really want to change some values within a tuple. So let me go ahead and change that to a list. Next, I want to explore membership testing with tuples and list. So I have this tuple and I want to say is B in the tuple, and that would result in the Boolean value of true. And then I can have a list and I can see, is this value of A not in the list, and that would result in false since it is fact in the list. Next up, I want to talk about dictionaries, so introducing yet another data type. And so for dictionaries, this is a way to provide a mapping between unique keys and their values. So here I am defining a new dictionary, and for this first key, I'm passing in the country of France. And then I use a colon, and in this value, so this is a tuple, and this tuple has the capital name of Paris and the population of Paris. So let me go ahead and execute this to go ahead and create that new dictionary. I can also add to dictionaries like this. So if I say capitals and I want to add a new key of Nigeria and provide the tuple values of Lagos and the population for that. So now when I print out capitals, I see my two dictionary items listed here. And I can also reference entries like I do in a dictionary, just like I can with a string list or tuple. So if I pass in that key, I would get back the value. And you can also update entries in the dictionary. You can update the values, but not the key. So here I would say, taking the capitals and entering that key of Nigeria, I can update the values by passing in a new capital of Nigeria and then seeing the population here. So when I do that, I see that my dictionary entries were updated. Specifically, that second dictionary entry has a new capital for Nigeria. I can use the length function on my dictionary, and that will return the number of keys particularly. And similar to the pop method for list, the pop item method randomly removes a key from the dictionary. So that's the one difference between pop and pop item. So here I'm, like it says, randomly removing a key from the dictionary. So there's no implied order. So that is kind of the interesting thing here. Because our dictionary only has 2 entries, it just goes ahead and kind of pops that last item there. But just a note of caution that is not always the case. There's a little bit more randomization there. And finally, when I print out that capitals dictionary again, I'm just left with that 1 entry. So next I want to get into control flow, functions, and libraries, and that's where I will end today. So control flow is a really great way to evaluate some statement and do some action as a result of that. So if I'm looking first at this if statement, and you might be very familiar with if statements, especially if you have programmed in other languages. Here, I have a variable y is equal to 6, and I say if 6 modulo 2 is equal to 0, print even. So very simple. That prints out even. I can start to explore more complex examples with an if statement. So I can introduce this concept of else. So if y, which is 7 modulo 2 is equal to 0, print even, else print odd. So this would, of course, go into that else statement and print out odd as a result. There is also LIF as another convention that I can try out. So here, just let's look at how this might execute. Here I have y is equal to 1. So if y modulo 2 is equal to 0, print even. It is not equal to 0. If y is equal to 1, print 1. So we know that y is equal to 1. So this is where this statement is going to actually stop. And I'm never going to evaluate this else part of the statement. So it would just go ahead and print 1 and break out of the if statement after that step. I'm going to skip through the exact exercises like I've been doing, but again, feel free to try those out on your own. Now let's talk about another type of loop called the for loop. So in this for loop, this provides a really easy way to iterate over a set of items. So here I have a list of colors, and I'm saying for each color in colors, print colors. And basically what's going to happen is this for loop is going to be executed 3 times. And as a result, I will have each of the list items printed out. Sometimes you will want to iterate over a list using the list index rather than items from that list. So here what I'm doing is saying for this variable I, in the range which is going to be this length of comp color, so that's going to be 3. So then I would print colors of I, comp colors I. So let's just see what happens when I do that. So what happens here is that I am left with red, green as one pair, yellow, purple as another pair, and blue, orange as that last pair. And remember from up above, this is looking at this list of colors, red, yellow, and blue, and kind of iterating through both of those lists at the same time. So this is a little bit different in where I pass in a specific range, which is just going to be a number in that case. And then I'm performing some action on that, printing the colors index and then printing out the comp colors list index. And now let's look at another example of range. And this one's probably a little bit easier to follow because I'm just passing in a range with an index value and then printing out each of those values. So this is going to iterate through this for loop 5 times and give me the values of 0, 1, 2, 3, 4. And I'm going to skip over this example, but I do just want to quickly talk through it. So here, this is a way to start to see some more complex examples of loops, and specifically nested loops. So here I have a for, and then I have another nested for, and then inside of that I have a nested if. So this is just a good example where we can start to see more complex combinations of these control flow statements. So I'm not going to go through this one like I mentioned, just kind of due to time constraints, but I do recommend trying this out on your own and just to see what happens when I run through this statement. Next, I want to talk about while loops. So while loops are another way to iterate through a statement until a logical condition is met. So let's look at this example of a Fibonacci series. So here I have two variables that I am assigning to two integers, 0 and 1. And I'm saying while b, so while this current value of b, which is 1, is less than 100, what I want to do is to say print b, comma, end is equal to this notation. And then I'm going to then change the values of the a and b variables. So a would now become b, and b becomes a plus b. So this is basically just defining the Fibonacci series. So when I execute that, I see the Fibonacci series up until 89, which is that last value of b before it gets to 100 and breaks out of that loop. So that is just one quick example of a while loop. Again, I won't go over any more examples for now, but feel free to try this out a little bit more and explore more while, for, and if control flows. Next, I want to bring up the idea of functions. So functions are another very critical part of what goes into a Python program. So functions are really a great way to define a set of functionality, or really to define one set of functionalities. So here I'm going to define this Fibonacci function. So functions should typically just do one particular thing, and it's really easy to define this function and then later call this function in your Python classes and programs. So here I am defining this function that is called fib. And this takes an n as a parameter, which I know is an integer just by hovering over that. And in the contents of this function, we basically see the same contents from the example up above of using that while loop. So here what I want to do is just to package up that code and put it in a function so that I can easily call the function. So let me go ahead and execute this. And now when I call the function, I can just go ahead and pass in any integer to that function and to see the result of what I get when I run that Fibonacci series with a given integer. And I'm going to pass over that example of list comprehensions, but again, feel free to try that out on your own. There is just one more thing that I want to get to in these examples for now, and that is importing modules. So importing modules is going to be, again, one of those very essential things of your Python programs. But if you're not using anything as part of the standard built-in functions into Python, you have to start to import some of those other libraries. Again, I mentioned there were extensive libraries, so you're going to have to get familiar with this convention of importing modules and libraries and being able to use them in your programs. So let's start with calling this factorial of 5. In here, I see that I get an error that says name factorial is not defined. So this indicates to me that I need to find a way to go ahead and define this function that I'm calling. So I know that the factorial function comes from the math module. So what I would do is to import this math module, and then I can call that function that's part of the math module. And if I want to take it a step further, I would use this convention here. So I would say from the math module, import this factorial function. And then that allows me to simply call the factorial function, which would give me the same result. So there's a couple different ways. You can either import the module and then use that module name to call the function, or I can do this all in a single line and say from this math module import the factorial function. So a couple different ways to do that, but this is going to be, again, a key part of any Python program that you write. So that's where I'm going to end this demonstration for now. But again, I've provided the steps to walk through this notebook, and I highly encourage you to do the setup steps of setting up VS Code, Python, the Jupyter Notebooks extension, and then run through some of these examples on your own. To close, I do just want to highlight a couple examples, but before I do, these are just one more reminder of the steps of how you can try this out at home. And then I want to provide some resources for further learning. So here, just take a moment to take a note of these links, and I'll quickly talk through them. So the first one is a really great 44-part video series that one of my teammates has created on learning Python. And there you'll find very bite-sized, snackable videos that are just a few minutes long of doing a deep dive into a lot of the examples and principles that I went over today. That second link, aka.ms/python-getting-started, will provide all the corresponding slides and sample code to that learning series. And those last two links are links to the Microsoft Learn library. Microsoft Learn is our online learning platform, and there we have a wide range of different topics that you can learn. So here are a couple great resources for Python in particular. So that first one will get you more familiar with Python syntax and get you writing some of your own applications. And the second one is just even more of kind of a dive into Python and starting to practice some of the things that we went over today. For additional learning on top of that, you can go to github.com/Microsoft/reactors. And you can go ahead and follow that link in particular, which would take you to our Introduction to Python for Data Scientists workshop. So I just walked through the very first section of that workshop. And in addition, there are other sections which allow you to dive into data science concepts and use the Python that you learned. If you go to that Microsoft Reactors repository, there's all of our other Reactor workshop content available there as well. So definitely check that out. We have other workshop content around data science, machine learning, AI, and more to come that we're actively developing. And if you just want to stay in touch, just make sure to continue to check out opportunities highlighted on both of our Twitter and Meetup pages. One last thing is that we provide free Azure for your next experiment. So if you do not have an Azure account, you can go to either of those two links at the bottom. So the students link is only for students, as you might imagine. But for both of these, you would get free Azure credit when signing up. So for the regular professional account, you would get $200 free credit for up to 30 days. And for the student account, you get $100 for 12 months. So that's all that I have for today. If you do have any questions about any of this, feel free to reach out. You can leave a comment. You can reach out to us on our Twitter or contact me directly. So thanks for watching. Bye.